1.3, we're going to be solving what are called literal equations. It's just like solving a linear equation, except the only difference is you're not going to have an exact answer. It's not going to say x equals 5. It's going to be a statement, like x equals b minus c. So it just means solve for the variable piece by piece, the variable they ask you to solve for. So right here, given this is so simple, you probably won't even need to take notes. You really won't. Watch. If I said that you solve for y, what would you do? Yep, so get it alone. So you subtract 2x from both sides. Subtract 2x. Then you have y is equal to 13 minus 2x. And you're done. You see what I mean by you won't get an exact answer, just a statement. If you did, David, you'd be awesome. I'm not worried about it right now. But if he was asking if we need to put it in standard form, great if you do. Yes. No, because we're not getting an exact real answer. We usually use those brackets or whatever, the little squigglies with an exact answer. Hey, just watch still. Just watch. Solve for y. What would we do? Subtract 4x, subtract 4x. Then you would have 2y equals 20 minus 4x. Divide by 2. Divide by 2. Now, everybody, you should remember this from Sec 3. This is a forbidden thing to do. You cannot divide across a subtraction sign. So I can't go, oh, 4 and 2 divide. I can't go, oh, 20 and 2 divide. That's across a subtraction sign. Don't do it. However, you do need to simplify if possible. So this is actually how we do it correctly. We say, okay, just look at the top. Is there anything in common? Yes. A 4 we could factor out, right? Everybody. So what I'm doing is simplifying now. We can divide across multiplication signs, but not addition signs. So on top, we have a 4 in common. Let's factor that out. So then, ignoring the bottom still, write what's left. Divide by 4, divide by 4. So in my first term, a 5 is left. True? Minus x. And then on bottom here, we have a 2. Now, like I said, you can divide across a multiplication sign, but not a subtraction sign. So now we actually can divide out the 4 and the 2. So that becomes a 2, and it's on top, right, everyone? 4 divided by 2 becomes 2. 2 divided by 2 and becomes 1. So our final answer would be y is equal to 2, parentheses, 5 minus x, and done. All good? Okay. Moving on. All right. I guess if you want to take notes on this one, you can. But you got to write like a maniac fast. So it says solve for y. Now, if it's a big, nasty thing, it's really not bad. You just got to go in the correct order and get y alone piece by piece. So as you're looking at this one, we're trying to get y alone. Don't we have this big divide by 7? That's the problem. How do you undo division? Multiplication. So wouldn't we multiply both sides by 7? Yes. So now look, 7 divides out. We have 2z. The key is rewriting it between each step and not being lazy, to be honest. Okay, keep in mind your goal. If you need to highlight it, you can. Like some people like to give themselves a little hint. Get that alone. So what would we do now? Very simple. Oh, you're saying to get rid of this, we got to bring it over minus 2z. Good. So that's gone. What else? Subtract 4e. Guys, we're trying to get y alone. Subtract 4e. Good job to the people that are answering. So now we have negative 3y is equal to 7 smiley minus 2z's minus 4e's. We can't put any of those together because they're not like terms. And we have one final step to get y alone. You guys divide by negative 3, right? That's what does multiplication. So y is equal to 7 smiley minus 2z's minus 4e's, and then that's all over negative 3. Now I'm going to point something out. Your answer sheet will never leave a negative on bottom. Fraction's fine, you know, whatever. But negatives, they just consider it, it's not that it's wrong, they don't write it like that. It's just considered not simplified. So what they do is they would take this negative. Do you guys know that, look, 2 divided by negative 1 is no different than negative 2 divided by 1. You guys know that? Okay, so I can take the negative and instead put it on top. So I would scribble that out, but it's negative 1 and you got to times it by all that stuff. So they would just change the sign on all of them on top. Negative 7 smiley plus 2z's plus 4e's, just so you know when you get to the answer sheet that you might have to make that adjustment to make your answer match it. All good? Moving on, next one. Okay, I'd rather you just watch this one because otherwise you're not going to be taking in all of the things. like all of the tricks. Okay, solve for big D. Now guys, one thing to note, look up here. If I take 1/2 and times it by x, that is no different than having x over 2. Here's why. When we multiply fractions, we multiply straight across. X is the same thing as x over 1. Do you guys see how when I multiply straight across, it becomes this? Okay, great. So look at this. If we have 1/3 x, what do we actually have? We have x over 3, everybody, correct? Do you guys see? Okay, let's rewrite it then, just a little prettier. 2p is equal to x over 3, and then it's still a times sign, right? D plus d. Do you guys see how it kind of makes it a little easier? Okay, what should we do to get big D alone first step? We have to divide by 3. That's a problem, right? Yeah. So we gotta undo. How do you undo division? Multiplication times by 3 times by 3. So isn't 3 over 3 gone? So now we have 6p is equal to x times big D plus little d. Next step, getting big D alone, guys. Nope, you wouldn't want to, but that was a good thought. What would we do? Divide by x. And now we have 6p over x is equal to big D plus little d. And last step, to get big D alone, we'd subtract d. Everybody, can I put that up here with this? No, it wasn't divided by x. That would be bad. So we have 6p over x. Out here we were then subtracting d, and that's equal to big D. Done. Not bad. That's just algebra. Okay, cool. Okay, if I said to you solve for x, this is x1, x sub 1, just solve for x. What should we do first? Guess what people do? They say multiply by b. Nope. You gotta first take care of this. So subtract c. c minus c equals a x1 x over b. What would we do to get big x1? It says divide by b. Let's get rid of it like you just said. Times by b. I just said times this entire side by b. Well, there's 2 things in that side, so I need parentheses. So we have b times t minus c is equal to a x1 x. Aren't those times signs if there's nothing written? Okay, so how do we get x? Yep, divide by ax1. Divide by ax1. Divide by ax1. And x is alone. Yeah? Okay, sweet. Okay, what I want you to do is, for a second, I'm going to have you practice a few in 1.3, some of the first ones, and then we'll come back and do some hard notes. This is so important, guys. Write this. You got to be really good note takers. Write this down. This is so important. If you have this happen, because I have people come first hour and say, I don't know how to do this. I'm like, remember, this is the one I told you about. So, guys, if you have this happen, look, it says solve for y. Well, what do you notice? We have 2 y's, and we can't put them together. That's the problem. We need 1 y. So when this happens, what you're going to do, so if you have 2 variables, if you have 2 of the same variable and you have to solve for that variable, this is what you do. First, get everything with that variable on one side of the equation. So say, get all of that variable, this is your notes, I'm trying to help you take better notes, variable on one side. And then you'll say in your notes, if you have 2, like you're making notes about if you have 2 of the same variable that you're solving for. That's the first step. The second step, you get everything else on the other side. All other stuff on the other side of the equation. On the other side of the equal sign. And then we'll go on from there. So look at this. 2y minus b plus g squared equals cy. You're like, I need to solve for y. Oh, but there's 2 y's. Well, oh yeah, this is the one where I need to get all the y's on one side of the equation and everything else on the other side. Yeah, we can subtract 2y over, because that has a y. So now we have negative b plus g squared equals cy minus 2y. Now you would check, do I need to bring anything over this way? Is there anything that doesn't have a y needs to come to the other side? But everything's good, right? Everything with a y is on this side, and everything that doesn't have a y is over here. You guys understand the 2 rules? Now your third step, write this down, because see how it says for a second. Your third step is to factor out the variable. So now look, since there's a y in each of these, I can factor that out. So what I'm going to do is factor out a y. When you factor something out, you technically divided it out, but you got to write it first. It didn't disappear into thin air. And then left is c minus 2. Well, look at that. Didn't take care of it. Now we only have one y. So then over here we have negative b plus g squared. And you say, okay, good. I only have one y now. Now I need to get y alone. It's a one-step problem from here. Yep. This is multiplication, so divide by c minus 2. Way to go. And now you say y is alone. So there's our answer. Does that make sense? Remember that rule. Yes. I'd write it again. I'm just going quick. Great question. Great question. Okay, solve for big X. Don't write this one down. This is a one-step problem. It just tricks people. People start overthinking these. Solve for big X. What would we do? Good. Divide by a minus 7 and we'd be done. Okay, look at 32 because this one is one of the easiest ones on there, and just because it has nasty, ugly words doesn't mean it's hard. So let's not freak out. Let's read this. It says, here is the surface area of a right circular cylinder. It's given by this formula. Area is equal to that big nasty thing, where r is the radius and h is the height. So I'm going to just make myself a little note. A stood for area because it's telling us. R is for radius, which makes sense. And h is for height. Cool, good to know. Now what it asks us in part A is solve for h. That is no different than what we've been asked to do previously. So I'm going to highlight it. We're solving for h. Luckily there's only one h, so we just piece by piece get h alone. What would be my first step? Good, minus 2 pi r squared, both sides. Rewrite it again. Area minus 2 pi r squared is equal to 2 pi r h. Yep, next step, we're going to get h alone. Thank you, Dave. We'll divide by 2 pi r. Wouldn't that work? Divide by 2 pi r. Ding, ding, ding. So we have h is equal to a minus 2 pi r squared all over 2 pi r. Now I'm going to ask you a very important question. Oh, look at that. Those 2 pi's could divide right out and r squared. No, because of the subtraction sign, you can't do it. Leave it alone. That's done. Okay, here we go. Part B, it says, determine the height. Well, that's why it had us solve for height. It did all the hard work for us. It says, give me the height of the right circular cylinder whose surface area, so they're giving us the area is 72 pi, and the radius is 4. It wants to know the height. So we literally just plug it in. It's like plug and shove. So let's plug it in where it's supposed to go. So our height is equal to our area, which is 72 pi's. Yeah? Minus 2 pi times our radius squared. So 2 pi times 4 squared is 4 times 4. So can I just write times 16 without anyone being mad? Okay. And then that's divided by 2 pi times the radius, which is times by 4. I should have just wrote 8 pi. Let's simplify this. Height is equal to 72 pi's minus 32 pi's, isn't it? All over 8 pi's. Oh, well, in this problem, we can actually combine like terms. 72 pi's times 32 pi's is 50 pi's, everyone, right? Our height is equal to 50 pi's over 8 pi's, which this is multiplication. We can't divide that out. 50 divided by 8. Is it? Oh. You're right. So we would have height is equal to 40 pi's over 8 pi, and then 40 divided by 8 is 5, and pi's are gone. Pi's is 5. So everybody see how it was actually really easy. We can divide across multiplication. That's why we were able to do it right there. Awesome. Okay, we are going to move on to the next lesson. Actually, I want you to practice for like 2 more minutes. So that's all I'm going to give you. How to go on. Now we're going to be solving linear inequalities. It's actually very similar, almost exactly similar to linear equations. So it's going to be actually really easy. It's just there's a difference only in one way. So let me show you. If I have, and don't write this down because you'll start taking notes when you need to. This is just getting you to realize what an inequality is. X minus 4 equals 2. That's an equation because there's an equal sign. Linear inequality, this is an inequality, not an equal sign. So solve for x, you'd add 4 and you get x equals 6. Does everybody see? We have one solution here. Now right here, you would pretend that's an equal sign and literally do the same thing. You add 4, you get x is less than or equal to 6. Now look, I used to get confused. Well, why are you confused with less than versus greater than? Like, how do you know? Watch, guys, you always read it like a book. Read from left to right. You always put that variable first, and then you read from left to right. So let's go. X is less than 6. So does that make sense? I hope. You never read this way. So yeah, 6 is greater than, stop. That's why you're getting confused. You always read from left to right. Make sense, everyone? Okay. All right, so guess what? It literally means exactly what it says. We have many solutions here. Any x value that is less than 6 is a solution. Did everybody hear that? So, for example, what's a solution what's less than 6? 5, 4, 3, and forever, right? Everybody? And 6, it says or equal to, so 6 is also a solution. Do you guys see how it just means multiple answers? Cool. No different. All right, so just look up here. This reads, x is less than 6. X is less than or equal to 6. X is greater than 6. X is greater than or equal to 6. When we start putting these in interval notation or on a number line, there's notation you use to specify if it includes 6 or does not include 6. So that's maybe something you'll want to make note of. Parentheses or holes mean not including. See, look, not including, so it's parentheses hole. And including would be a bracket or a closed circle. Make sense? We've known that. We've used this in math all the time. Bracket means including. Parentheses means not including. Closed circle means including. Open circle means not including. So just some things. You will just be looking up here for right now. Okay, so getting the answer is the easy part. They make us write the answer 3 different ways. So there's what's called set builder notation, interval notation, and then they want you to also be able to graph it on a number line. So we just solved this one. We added 4 over and we got x values less than 6. That was in our solution set. So set, we would draw a set, just like we did on day 1, for x, such that any x value is less than or equal to 6. Everybody good? It's just like day 1. Then right here, in interval notation, think about it. Any x value is below 6. It goes on that way forever. So it's coming in hot from negative infinity, and boom, it's 6, and then stops. It was equal to, so there's a bracket. Do you guys see? Making sense? Okay. Now on a number line, you draw it like this. So you would draw in a number line. You put in a 0, then you would go over 1, 2, 3, 4, 5, 6. And it's any x value less than 6, so I pointed my arrow this way, and then it includes 6, so I put a bracket here. You could have also, instead of the bracket, done a closed circle and pointed it this way. I don't care how you do it. Yes, it wants all 3. You have to be pro really at all 3. I want you to notice something. The arrow points that way. Isn't that how the arrow pointed? That way. It's kind of a trick. Kind of a nice trick to help you see where it goes. Okay, watch. A couple reminders. There is one rule you do have to remember. We solve it just like normal. However, if you ever, this is a rule you might want to write down in your notes right here. If you're solving with an inequality and you ever multiply or divide by a negative number, you have to change the sign of the inequality. Not if you add a negative number, not if you subtract a number, not if you, only if you multiply or divide both sides by a negative, do you change the inequality sign, and I'm going to show you why in just a second. You have to remember that rule. Okay, so I'm just going to show you, and then show you why, and then all you have to do is remember the rule. See, I wouldn't even take notes right here. I'd just take in why this works. So if we're just using the rule, you'd say, okay, I'm solving for x. I need to divide both sides by -4. Oh crap, I just divided both sides of the equation by a negative. Therefore, I need to change this inequality this way. And then we get -5. X is greater than -5. Now here, watch, this is why that is the way it is. This is why this rule exists. I could also say to you, okay, you're only allowed to solve for x if x is positive. You got to use algebra to make x positive. So watch, couldn't I make this positive 4x by adding it over here? Why not? Is that changing the problem? No, I'm doing the same thing to both sides of the equation. So I could add 4x to both sides. So now, guys, people always go like, what happened here? Well, -4 plus 4 is 0. 0 is just a number, so write in your zeros. So we have 0 is less than, we have now 20 plus 4x. Now x is positive, so we're good to go. Solve for x piece by piece using algebra. So when I subtract 20, negative 20 is less than, I'm reading it from left to right, less than 4x. So now what we would do is divide both sides by 4, and we would get negative 5 is less than x. Now let me clarify something. We would never write our answers without x being first. So I'm going to write it correctly. So I'm going to switch this. Look at the chomper. I'm chomping down, chomp, chomp on x. Do you see it? Chomp on x. So when I rewrite it, it's got to still stay chomping on x, or else I've changed it. You guys see? This is not changing it. Chomp on x still, and negative 5. Boom, boom, same thing. Okay. Here we go. Don't write it down. Too easy, too easy. What would I do to solve for x? None of these are you're going to write down for a second. You're just going to watch. Divide by negative 8. So now we need to change the sign. X is less than negative 4. Okay, so if you need to, think about what that would be. So any x value below 4. So negative 4, negative 5, negative 6. Isn't that true forever? Is it including negative 4? No. Okay, cool. So set builder notation. This is just to put it in perspective of anything that's an answer. So my set, oh, this is backwards. I did this, I think, no, this is good. Okay, so we have the set for x such that x is less than negative 4. Interval notation. Okay, we're going this way forever. Isn't that negative infinity up to negative 4? Good. So the lowest value would be negative infinity up to negative 4. Isn't that the highest value? Parenthesis, parenthesis. Infinity always gets a parenthesis. It's not a number, it's a place. So, all good. On a number line, we draw out a number line. We put a 0 always over negative 1, 2, 3, 4. I only care if you label that. And then it's point, look, it points that way. Makes sense. So we're going to start here, point it that way, and it's not including. So you can put a parenthesis or a open circle. Done. Next one. Don't take note. Yes. No. Because it's not including negative 4. See how there's not an equal sign right here? Good question. I like it. Okay, watch. Still too easy to take notes on. Solve this. What would we do? Add 5. Add 5. Negative 6 is x. Negative 6x is less than 18. Now what? And then we say, oh, we just did that thing that we have to change the inequality sign. Any x value greater than negative 3. So think about it. Start at negative 3. Anything greater than that. Isn't negative 2 larger? Negative 1, 0, 1, comma, on forever. Also not including. So our set, they're set for x such that x is greater than negative 3. Interval notation. Our lowest value is? Good. Negative 3. And it's going to? Infinity. And it's not including. And infinity always gets a parenthesis. There's 0, negative 1, 2, 3. There's negative 3. Look, the arrow points that way. We're going that way. And then it's not including, so we could do a open circle or parentheses. I'm switching to the other way. Okay, still just watching because it's still super easy. Solve for x. So we would subtract 5x. We gotta put our x's together. So we would have 3x plus 3 is greater than or equal to negative 9. Subtract 3, am I right? 3x is greater than or equal to negative 12, right? Divide by 3. Guess what people do? They say, oh, negative. No, you didn't divide by a negative. The sign stays the same. You see what people do? Don't do it. So it's still x is greater than or equal to negative 4. Let's not draw out. I was drawing out that thing, but I think you're getting it. Look, it's pointing this way. Starting at negative 4, we're going that way. So set for x such that x is greater than or equal to negative 4. Our interval, what's the lowest value? Negative 4. Is it including? Negative 4, and then it's pointing that way, so it must be going to infinity. Our number line, we get the picture here. 0, 1, 2, 3, 4. And it's pointing that way, and it is a bracket. Yeah? Okay. Okay. Something bigger and uglier, we just do the same thing. You shouldn't be taking notes because we have solved this on day 1. But let's just quickly show you what's going to happen. So you'll just do the algebra, distribute what you need to. So distribute 5x minus 10 plus 2. Combine like terms on this side. Okay, good. 2x plus 4 is greater than or equal to, combine like terms, 5x minus 8 Now I'm going to bring the x's together. Subtract 2x over here. 4 is greater than or equal to 3x minus 8. Shouldn't I add 8? So we have 12 is greater than or equal to 3x. Divide by 3, divide by 3. So we now have this. 4 is greater than or equal to x. We don't write x second. We write x first. So we go like this. The set for x such that. Now look, it's chomping 4. You gotta keep it that way. Gotta chomp 4. You see how the chomping helps you not mess it up? Yeah. Okay. Interval. Now look, it's pointing this way. It's going to negative infinity, isn't it? Okay. Pointing this way. So our largest value must be 4. So we're coming in hot from negative infinity up to 4. It includes 4 and boom. Number line, you get the picture. All right. What would you do here? No different. Pretend that's an equal sign. What do you do? It's the exact same thing. Technically, we're getting a common denominator, right? 2 over 2, right? Think of it like that just because it'll make the harder ones easier. And you say, I have a 4. When we're solving these, remember, once you have a common denominator, you can ignore it when solving. So we just have literally 3x plus 1 is less than 2. Subtract 1, yeah? So 3x is less than 1. So then x is less than 1/3, yeah? Think about it. You start at 1/3, and then you're going to negative infinity, because it's less than 1/3, so the set for x such that x is less than 1/3. It's pointing that way, so it's going to negative infinity, and it's stopping at 1/3, not including, and you get the picture. What would I do here? Pretend it's an equal sign. Common denominator, guys. So shouldn't I put this over 1? That's where people usually mess it up. Okay, so times by 2 over 2, and then times by 6 over 6, and now you say, oh, 6, 6, 6. I can ignore that. 4 minus 5x. It's greater than 12. Yep. Doing too well. Times 4 minus 4. Negative 5x is greater than 12, 11, 10, 9, 8, right? And divide by negative 5. Oh, what just happened? Switch the sign. Negative 8/5, and it's pointing that way. So it's going to negative infinity, isn't it? Okay, cool. Making sure we're seeing it. X value such that x is less than negative 8/5. Going that way to negative infinity, and it's stopping at negative 8/5, parenthesis, parenthesis. I'm not drawing in the number line because that's the easiest part. Do you agree? Okay. With this one, is it any harder? No. Well, I'm just going to make a point here. You would take negative 5, you'd distribute it in, right? You would take 3, and you got to distribute it in there and there, because there's 2 terms. And then you would take the 3 and distribute it into those, the negative 3. You guys see? Do I need to keep going? Yes or no? Yes, sir? Just saying, it's just like a parenthesis. They just don't want to do parentheses around parentheses, but it is the same thing. So you would, it's just telling you 3 times all that stuff. So do you see how there's a 1, 2 terms? You put the 3 with this, and then the 3 right here in front, and then you distribute negative 3 through. Good question. Okay, what would I do here? Okay, good. Get a common denominator, 3 over 3. So then we would have 4x minus 3 is less than 9, and we continue. Okay, I think we get the picture. How about you guys? You think you get the picture? Ready to practice on your own? Okay, I want you to practice on your own. Do some on 1.4. Go do some of the hard ones.